Every few lifetimes, something crosses our sky that does not belong here. Something that arrived not from the scattered debris belt beyond Neptune, not from the distant reservoir of icy wanderers we call the Oort cloud, but from somewhere else entirely. This time, it came from another star. On the first day of July in the year 2025, astronomers working with the Atlas Survey Telescope in Rio Hurtado, Chile, spotted a faint smudge of light moving against the background of stars. At first glance, it looked like any other comet, a frozen visitor from the outer reaches of our own solar neighborhood. But as more observations poured in from telescopes around the world, something became unmistakably clear. This object was moving too fast. Its trajectory was all wrong. When researchers traced its path backward, through space and time, they realized it had not been born in our solar system at all. It had come from the space between the stars, drifting for millions, perhaps billions of years, until it stumbled into our corner of the galaxy by sheer cosmic chance. They named it 3I/Atlas, the third confirmed interstellar object ever discovered. The first, 1I/Oumuamua, stunned the world in 2017 with its strange cigar shape and unexplained acceleration. The second, 2I/Borisov, arrived in 2019 and behaved more like a typical comet, albeit one from an alien solar system. Now, 3I/Atlas joins that exclusive list, a messenger carrying secrets from a sun we will never see. This is not a rock that belongs to us. It formed in another star system, under different skies, shaped by forces and conditions we can only guess at. Somewhere out there, perhaps hundreds or thousands of light years away, there is a star around which this object once orbited. That star might still be shining, pouring light into the void, warming planets we will never visit. Or it might have died long ago, collapsing into a white dwarf, or exploding as a supernova, scattering its remains across the galaxy. We will probably never know. But what we do know is that 3I/Atlas was once part of that system, born in its protoplanetary disk, shaped by its gravity, until something went wrong. Something, a close encounter with a giant planet, a passing star, a collision with another body, kicked this object out of its home. It was accelerated to escape velocity, flung into interstellar space like a stone from a sling, and then it traveled. For millions of years, perhaps billions, it drifted through the darkness between stars, moving at tens of kilometers per second through a void so empty that it might go centuries without passing another object. There was no sunlight to warm it, no planets to perturb its path, nothing but the faint pull of distant stars, tugging it this way and that as it wandered through the Milky Way. During that time, cosmic rays bombarded its surface, breaking down molecules, creating new compounds, darkening and reddening the ice and rock. It accumulated a coating of organic material, carbon-based compounds formed by radiation and chemistry in the cold of space. It became, in a sense, a time capsule, preserving the conditions of its birth while slowly aging in the interstellar medium. And through it all, it kept moving, following a path determined by the initial kick that sent it into exile and the gravitational influences of every star it passed along the way. Then, by chance, its trajectory brought it into our solar system. It approached from the general direction of Sagittarius, the constellation that marks the center of our galaxy. It fell toward the sun, accelerating under the pull of gravity, its speed increasing as it descended into the inner solar system. And as it got closer, as sunlight finally began to warm its surface after eons of cold, something remarkable happened. The ice began to sublimate. Water, carbon dioxide, carbon monoxide, and other volatile compounds trapped in the nucleus started to turn directly from solid to gas, escaping into space and forming a glowing cloud around the solid core. The comet woke up. It became active. And that is when we saw it. The discovery was not instant. Astronomers pieced together earlier images from archives, what they call pre-discovery observations, stretching back to mid-June. That means 3I/Atlas had been visible for weeks before anyone realized what they were looking at. It was hiding in plain sight, just another faint dot in a sky crowded with millions of them. The Atlas survey, designed to scan the sky repeatedly looking for anything that moves or changes, captured it in multiple images. But it took time to analyze the data, to calculate the orbit, to realize that this was not an asteroid or a comet from our own system. Only when enough data points lined up did the truth emerge. This was not one of ours. The announcement came quickly after that. The Minor Planet Center, the international organization responsible for cataloging small bodies in the solar system, issued a circular confirming the interstellar nature of the object. Observatories around the world turned their instruments toward it, capturing images, spectra, and photometry. Within days, astronomers had enough data to calculate a preliminary orbit, to estimate its size and composition, and to predict when and where it would be visible in the months to come. The scientific community mobilized with remarkable speed, recognizing that this was a rare opportunity, a chance to study material from another star system before it disappeared forever. But this was not just a scientific event. News of the discovery spread quickly beyond astronomy journals and academic conferences. It appeared in newspapers, on television, across social media. People who had never looked through a telescope, who could not tell a comet from an asteroid, suddenly found themselves captivated by the idea of a visitor from another star. There was something romantic about it, something that touched a nerve deeper than curiosity. We were not alone, not in the sense of intelligent life, but in the sense that our solar system was not isolated. Objects could cross between stars. Material could be exchanged. The galaxy was more connected, more dynamic, more alive than we had imagined, and for some people, the timing felt significant. 3I/Atlas was discovered in the summer of 2025, a year that had already been marked by upheaval and uncertainty. Climate patterns were shifting in ways that frightened scientists. Political systems were strained by division and instability. Technology was advancing faster than society could adapt, creating both opportunities and dangers that no one fully understood. In that context, the arrival of an interstellar visitor felt like more than coincidence. It felt like a sign, a marker, a cosmic punctuation mark on a sentence humanity was still writing. 3I/Atlas poses no threat to Earth. It will not strike our planet, will not pull us off course, will not rain fire from the heavens. The closest it will ever come to us is about 1.8 astronomical units, roughly 170 million miles away, a distance so vast it is almost meaningless to the human mind. For context, that is farther than the Sun is from Earth. This visitor will glide through the inner solar system, like a stranger passing through a quiet town at night, visible for a brief window before disappearing over the horizon. There is no danger, but there is mystery. And mystery, in a world that often feels too knowable, too mapped and measured and understood, is a rare and precious thing. As the comet continues its journey inward, it is not just astronomers who are watching. Writers, artists, mystics, and everyday people who have never paid much attention to the sky are looking up, wondering what it means. They are reading about the blue star prophecies of the Hopi, about ancient omens and cosmic calendars, about the possibility that this visitor carries a message or a purpose that goes beyond physics and chemistry. They are asking questions that science cannot answer, not because the questions are too hard, but because they are the wrong kind of questions for science to address. Does the universe have intention? Is there meaning in rare events? Are we part of a larger story? Or are we just witnesses to random motion in an indifferent cosmos? These are not new questions. Humans have been asking them for as long as we have had language. But 3I/Atlas gives them new urgency, new focus. It is easy to dismiss cosmic questions when the cosmos feels distant and abstract. But when a piece of the cosmos appears in our sky, when we can point to a specific object and say, that came from another star, the questions become concrete. They become personal. And that is when they start to matter in a way that goes beyond intellectual curiosity. So 3I/Atlas is not just a comet. It is a catalyst. It is a mirror. It is a test of how we think about ourselves and our place in the universe. And it is a reminder that the sky is not empty, that the space between stars is not a void, that the galaxy is full of wanderers and travelers and visitors that move through the dark without knowing or caring that we exist. We are one planet, circling one star, in a galaxy of hundreds of billions. And sometimes, just sometimes, something from out there comes close enough for us to see. This is one of those times, and what we choose to do with it, how we choose to understand it, what stories we tell about it, will say more about us than it ever could about the comet. The path. It cuts through our solar system. To understand why some people believe 3I/Atlas carries meaning, you have to see the path it is tracing through our cosmic neighborhood. This is not a random tumble through empty space. It is a precise high-speed arc that cuts through the inner solar system with an elegance that feels almost intentional. 3I/Atlas is on what scientists call a hyperbolic trajectory, a path shaped like an open curve rather than a closed loop. Objects that belong to our solar system, planets, asteroids, comets, all follow elliptical orbits. They circle the sun in predictable patterns, bound by gravity, locked into an eternal dance that repeats over and over. The Earth takes 1 year to complete its orbit. Jupiter takes 12. Even distant comets from the Oort cloud, though they take thousands or millions of years to complete a single loop, are still bound to the sun, destined to return eventually. But 3I/Atlas does not dance. It races. Its orbit has an eccentricity value of around 6, a number so far from 1 that it leaves no doubt this object is just passing through. Eccentricity is a measure of how stretched out an orbit is. A circle has an eccentricity of 0. An ellipse has an eccentricity between 0 and 1. A parabola, the borderline case between bound and unbound motion, has an eccentricity of exactly 1. Anything greater than 1 is hyperbolic, meaning the object will never return. 3I/Atlas has an eccentricity around 6, which means its orbit is not even close to being bound. It is moving so fast that the sun's gravity can bend its path, can curve it inward, and then back out, but cannot capture it. Once it swings past the sun, it will escape the solar system entirely, accelerating back into interstellar space at a velocity of roughly 58 kilometers per second. That speed is staggering. To put it in perspective, the fastest spacecraft ever built by humans, the Parker Solar Probe, reached speeds of about 192 kilometers per second at its closest approach to the sun, but only by falling deep into the sun's gravity well. 3I/Atlas is moving at a significant fraction of that speed, not because it is powered by rocket engines, but simply because it is still carrying the kinetic energy from whatever event ejected it from its home star system millions of years ago. It has been coasting through space at interstellar speeds for longer than human civilization has existed, and it will continue coasting long after we are gone. When the comet was first discovered in early July, it was already traveling at about 137,000 miles per hour. As it falls closer to the sun, it will move even faster, pulled by gravity into a tight, swift turn before being flung back out into the void. At perihelion, the closest point to the sun, it will be moving at its maximum speed, racing around the star in a matter of hours before heading back out toward the outer solar system and beyond. The entire time it spends in the inner solar system, from discovery to departure, is just a few months. Blink and you miss it. And once it is gone forever. But speed is only part of the story. What makes this visitor truly strange is the angle of its approach. 3I/Atlas is moving in a retrograde orbit, meaning it is traveling in the opposite direction compared to most of the planets. Its orbital inclination is about 175 degrees, almost perfectly backward, relative to the plane in which Earth, Mars, Jupiter, and the others revolve. This is not a gentle alignment. It is a near head-on encounter with the architecture of our solar system. The ecliptic plane is the flat disk where most planetary orbits are concentrated. If you imagine the solar system as a record player, with the sun at the center and the planets circling like grooves on a vinyl disc, then the ecliptic is the surface of that disk. Most comets and asteroids from our own system orbit close to this plane because they formed from the same rotating disk of material that eventually condensed into the planets. But 3I/Atlas is not from our system. It came from a different star, with a different orbital architecture, and its path reflects that foreign origin. Despite this backward motion, the comet's path lies close to the ecliptic plane. That means it is not swooping in from some wild angle above or below the solar system, like a bird diving from the sky. It is threading its way through the inner region, crossing near the orbital paths of Venus, Mars, and Jupiter, without ever colliding with anything. It is like watching someone weave through traffic at high speed, moving in the wrong direction, never touching a single car, and then disappearing over the horizon before you can even process what you saw. The precision is eerie. The timing is perfect. And even though we know it is all just physics, just gravity and momentum playing out according to the laws of motion, it is hard not to see intention in it. The closest point to the sun, called perihelion, will occur around October 30th, 2025, at a distance of about 1.4 astronomical units. That puts it just inside the orbit of Mars, in the region where the asteroid belt begins to thin out and the inner solar system transitions to the outer. At that moment, 3I/Atlas will be bathed in intense sunlight, heating its surface to temperatures high enough to sublimate not just water ice, but also more volatile compounds like carbon monoxide and methane. The coma, the glowing cloud of gas and dust surrounding the nucleus, will reach its maximum brightness and extent. And if the comet behaves like typical comets from our own system, it might even develop a tail, a long streamer of dust and ionized gas pushed away from the sun by radiation pressure and the solar wind. But observing perihelion will be difficult. By early September 2025, the comet will pass too close to the sun's glare to observe safely from Earth. It will disappear into the light, hidden from view, effectively invisible for several weeks. This is a common problem in astronomy. Objects that pass close to the Sun become difficult or impossible to observe from Earth because they are lost in the overwhelming brightness of the star. Telescopes pointed in that direction risk damage from solar radiation, and even if they did not, the comet would be impossible to separate from the Sun's glare. So for a critical period, right when 3I/Atlas is at its most active, we will be blind to it. It will re-emerge on the other side in early December, giving astronomers a second chance to study it before it leaves forever. By then, it will be moving away from the Sun, cooling down, becoming less active as the sunlight weakens. The coma will shrink. The tail, if there was one, will fade. The comet will grow dimmer and dimmer as it accelerates outward, passing the orbit of Mars, then Jupiter, then Saturn, until finally it crosses the edge of the solar system and returns to interstellar space. And at that point, it will be too faint for even the most powerful telescopes to track. It will become just another invisible speck in the vastness of the galaxy, one more wanderer among trillions. There is something haunting about that timing. 3I/Atlas will be visible to humanity for only a few months, a brief window in which our species can witness something that has been traveling for eons. After December, it will fade into the distance, becoming too faint to track, and eventually, it will be swallowed by the black. No telescope will ever see it again. No future generation will have a chance to study it. This moment, right now, is the only time in all of human history that we will share the sky with this particular visitor, and that makes every observation, every spectrum, every image irreplaceable. There are no second chances with objects like this. And yet, despite the elegance of its path and the precision of its trajectory, there is nothing special about 3I/Atlas in a cosmic sense. Space is full of objects moving at incredible speeds, crossing impossible distances, passing through systems without purpose or awareness. The galaxy is not empty. It is filled with debris from billions of years of star formation and planetary system evolution. Every star that forms ejects material. Every planetary system that stabilizes scatters objects into interstellar space. Over time, the galaxy becomes crowded with these refugees, these orphans, these wanderers that no longer belong to any system. Most of them drift in isolation forever, never coming close to another star. But some, by chance, fall into the gravity wells of other systems. And when they do, if anyone happens to be watching, they become interstellar visitors. The laws of physics do not care about meaning. Gravity pulls, momentum carries, and objects go where the math says they will go. There is no script, no plan, no cosmic choreographer arranging the movements of comets and planets for dramatic effect. 3I/Atlas is here because the numbers worked out that way, because the initial velocity it received when it was ejected from its home system, plus the gravitational perturbations it experienced during millions of years of travel, plus the pull of the sun and planets, all added up to a trajectory that brought it through our neighborhood at this particular time. But humans are not built to accept randomness so easily. When something as rare as this appears, tracing a path that feels deliberate, cutting through the inner solar system with precision and speed, it is almost impossible not to search for a reason. We see the retrograde orbit and wonder if it is symbolic. We see the timing of the discovery and wonder if it is meaningful. We see the brief window of visibility and wonder if it is a message, a warning, a test. The comet does not wonder. It does not question. It simply moves. But we do. And in our wondering, we create the very meaning we are searching for. Some say the timing is too perfect. 3I/Atlas was discovered in 2025, a year marked by global upheaval, climate crisis, political instability, and rapid technological change. It approaches perihelion in October, a month that carries its own weight of symbolism in many cultures. It will be visible during a time when humanity is asking fundamental questions about its future, about whether we can survive the challenges we have created, about whether we are alone in the universe, about what our place in the cosmos really is. And in that context, an interstellar visitor feels like more than coincidence. It feels like punctuation, like an exclamation point at the end of a sentence we have been writing for centuries. Others point to the way it crosses the inner solar system, almost as if sampling our neighborhood before moving on. It does not strike anything. It does not linger. It simply passes through, close enough to be seen but far enough to be safe, like a traveler stopping at a crossroads before continuing on a journey. There is elegance in that, a kind of cosmic politeness, even though we know it is just physics. The comet is not choosing to avoid us. It is not being careful. It is simply following the path that was set millions of years ago. But knowing that does not change how it feels. And feeling, in the end, is what shapes human experience. That is where the ancient stories come in. Because long before we had telescopes and orbital mechanics, humans were already watching the sky and trying to make sense of the visitors that appeared there. Comets were always special. They were bright, they moved, they changed, and they did not follow the predictable patterns of planets and stars. They were anomalies. And anomalies demanded explanation. So our ancestors created stories, myths, prophecies, omens. They saw comets as messengers from the gods, as harbingers of change, as signs that the natural order was being disrupted. And some of those old stories, written in languages we barely remember, carved in stone or passed down through oral tradition, seem to describe something that looks an awful lot like what is happening right now. Ancient eyes on a restless sky. For as long as humans have had language, they have looked up at the night sky and seen more than just stars. They have seen omens, messages, warnings, and promises. The sky was never just a backdrop, a collection of bright points against the black. It was a book, written in light, that changed from night to night, season to season, year to year. And when something unusual appeared, a bright new star, a wandering light, a streak of fire across the darkness, it was never dismissed as random. It always meant something. The ancients did not have telescopes. They did not have spectrographs, or orbital calculations, or an understanding of gravity. But they had eyes, and they had time, and they had an intimate relationship with the sky that most modern people cannot imagine. In a world without electric lights, without cities glowing orange against the horizon, without the constant distractions of screens and technology, the night sky was overwhelming. It was vast. It was beautiful. And it was alive in ways that went beyond the physical. The stars moved in predictable patterns, rising and setting with the seasons, marking time, guiding travelers, telling stories. But sometimes, something unexpected would appear. And when it did, it demanded attention. Comets in particular carried a weight of significance that went far beyond their physical presence. They were different from stars, which were fixed points in the heavens, and different from planets, which wandered but followed predictable paths. Comets appeared without warning, brightened and faded, developed tails that stretched across the sky, and then disappeared. sometimes never to be seen again. They were transient. They were unpredictable. They were liminal, existing at the boundary between the heavens and the earth, between order and chaos, between the known and the unknown. And so they became symbols of change, of disruption, of moments when the normal rules no longer applied. In ancient Mesopotamia, one of the earliest civilizations to keep detailed astronomical records, scribes observed the sky every night and wrote down everything they saw. These observations were not just scientific curiosity, they were state policy. The Mesopotamians believed that the gods communicated their intentions through celestial events, and that by studying the sky, priests and astrologers could predict the fates of kings, the outcomes of wars, the success of harvests. Comets were particularly significant. A bright comet appearing in a specific part of the sky might signal the death of a king, the rise of a new dynasty, the outbreak of plague, or the beginning of a war. The position, brightness, and movement of the comet all carried meaning, and the priests would interpret these signs to advise the rulers. These were not superstitions in the dismissive sense. They were sophisticated attempts to find patterns in a chaotic world, to impose order on events that seemed random and terrifying. The Mesopotamians did not understand the physical nature of comets, but they understood correlation. They kept records. They noticed that when certain types of comets appeared, certain types of events tended to follow. Whether the correlation was real or imagined, whether the comets actually influenced events, or whether human memory simply selected and amplified the connections, is almost irrelevant. The belief shaped behavior. Kings made decisions based on comet sightings. Wars were delayed or hastened. Rituals were performed. And in that sense, the comets had power, not because of what they were, but because of what people believed they were. The Romans inherited and expanded on these traditions. They saw comets as harbingers of change, often interpreting them as signs of impending death for emperors or the collapse of political orders. One of the most famous examples occurred after the assassination of Julius Caesar in 44 BCE. A bright comet appeared in the sky during funeral games held in Caesar's honor, visible even in daylight. Many Romans interpreted this as Caesar's soul ascending to the heavens, proof that he had become a god. Others saw it as a warning that the Republic was ending, that the old order was dying, and a new one was being born. The historian Pliny the Elder, writing a century later, described it as one of the most significant comets in Roman history, a turning point that marked the transition from republic to empire. Pliny wrote extensively about comets, cataloging different types and their supposed meanings. He described bearded stars with long streaming tails, dagger stars that pointed like weapons, and lamps that glowed with a steady light. Each type was believed to carry different omens. Some comets were good signs, heralding peace or prosperity. Others were evil, bringing war, famine, or plague. Pliny's writings are a fascinating mix of observation and interpretation, of genuine curiosity about the natural world, and deep cultural anxiety about what unusual celestial events might mean. He was trying to make sense of the sky using the best tools available to him, which at the time were not scientific instruments, but historical records and cultural memory. In China, astronomers recorded comets for thousands of years, creating one of the longest continuous astronomical records in human history. Chinese scholars categorized comets by shape, color, and movement, giving them poetic names like broom star or long-tailed star. Some were seen as brooms sweeping away the old, clearing space for the new. Others were spears aimed at enemies, or banners announcing the arrival of important figures. The emperor, who ruled by the mandate of heaven, was particularly sensitive to celestial omens. A comet appearing in the wrong part of the sky, at the wrong time, could be interpreted as a sign that the emperor had lost the favor of heaven, that his rule was illegitimate, that rebellion was justified. More than one dynasty fell, partly because of such interpretations, because the belief in celestial omens gave legitimacy to political movements that might otherwise have been suppressed. The Chinese records are remarkable, not just for their longevity, but for their detail. Some observations include information about the comet's position relative to specific stars, its brightness, the length and direction of its tail, and how long it remained visible. In some cases, modern astronomers have been able to match these historical records with known comets, like Halley's Comet, which appears in Chinese records going back more than 2,000 years. This demonstrates that while the interpretations were cultural, the observations themselves were accurate. The ancients were seeing real objects, real phenomena, and recording them with care and precision. They just did not have the framework to understand what those objects actually were. Indigenous cultures across the world developed their own interpretations of comets, shaped by their unique cosmologies and experiences. Some Native American tribes saw comets as ancestors returning to visit the living, souls traveling between worlds. Others believed they were spirits, or messengers, bringing warnings or instructions from the Creator. In some Australian Aboriginal traditions, comets were seen as celestial campfires, places where ancestors gathered in the sky. In Polynesian cultures, they were navigational signs, markers that helped voyagers find their way across vast stretches of ocean. The details varied enormously from culture to culture, but the core idea was universal. The sky was not random. It was purposeful. It was a realm where the gods lived, where the ancestors went after death, where the fundamental forces that shaped human life played out in patterns of light. And anything that appeared in the sky, especially something as dramatic and unusual as a comet, carried intention. It was not just a physical object. It was a sign, a message, a moment when the boundary between the mortal world and the divine became thin. This is not superstition in the dismissive sense. It is pattern recognition, the same cognitive ability that allowed humans to survive and thrive. Our ancestors needed to see patterns in order to predict weather, track seasons, find food, and avoid danger. The brain that can recognize a pattern in animal tracks or the behavior of clouds is the same brain that looks at a comet and asks, "What does this mean?" That question is not a flaw. It is a feature. It kept us alive. The problem is that the same mechanism that allows us to spot real patterns also makes us see patterns where none exist. And over time, the two become tangled together, real and imagined, signal and noise, until it becomes impossible to separate them without tools and methods that most cultures did not develop until very recently. But even knowing that, even understanding the cognitive biases and the lack of scientific knowledge that shaped ancient comet lore, it is hard not to feel the power of those old stories. They tap into something deep, something that goes beyond rational analysis. They speak to the feeling that we are part of something larger, that the universe is not indifferent, that the things we see and experience are connected in ways that matter. And when a modern interstellar visitor appears in our sky, when 3I/Atlas comes racing through the inner solar system at a time of global upheaval, it is almost impossible not to hear echoes of those ancient warnings. The Hopi people of North America have a prophecy that has drawn particular attention in recent months, especially in connection with 3I/Atlas. According to modern retellings, the prophecy speaks of a blue star Kachina, a celestial sign that will appear in the sky to herald the end of the current world and the beginning of a new one, often called the fifth world. The blue star is supposed to mark the start of a period of purification, a time when imbalance and corruption are cleared away to make room for a renewed existence. It is not a gentle transition. It is upheaval, destruction of the old to make way for the new, a reckoning for those who have lived out of harmony with the earth and each other. The prophecy includes several signs that some people today interpret as references to modern technology and global events. One sign is a dwelling place in the sky, which is now often linked to space stations like the International Space Station. Another is a spiderweb across the Earth, which some see as satellites, global communication networks, and the Internet. A third sign mentions the sea turning black, which has been connected to oil spills and ocean pollution. A fourth speaks of the weather becoming strange, which resonates powerfully in an age of climate change. And then there is the blue star itself, a celestial visitor that will appear as a marker that the time of purification has arrived. It is important to note that scholars who study Hopi culture have pointed out significant complications with this prophecy. The widely quoted version may not be as ancient as it appears. Some anthropologists suggest it is primarily a 20th century interpretation, influenced by contact with outside cultures and shaped by modern concerns, rather than being a prophecy passed down unchanged for centuries. The Hopi have complex and varied oral traditions, and different clans and communities have different versions of their sacred stories. Reducing them to a single unified prophecy about a blue star does not do justice to the depth and diversity of their culture. And Hopi elders themselves have expressed frustration with the way their traditions have been appropriated, simplified, and reinterpreted by outsiders looking for validation of their own beliefs. But whether the prophecy is ancient or modern, whether it comes from authentic Hopi tradition or from 20th century syncretism, it resonates with people today because it speaks to a feeling that is hard to ignore. The world does feel like it is changing. Climate patterns are shifting in ways that frighten scientists. Ecosystems are collapsing at rates not seen in millions of years. Political systems are strained by division and instability. Economic inequality is growing. Technology is advancing faster than society can adapt, creating both opportunities and dangers that no one fully understands. And in the middle of all this, an interstellar visitor appears in the sky, glowing blue-white against the black, arriving from somewhere beyond our reach. It is not hard to see why some people connect the two. The prophecy does not need to be accurate to be meaningful. It does not need to be ancient to be true in the emotional sense. What matters is that it gives structure to uncertainty, that it turns random events into a narrative with a beginning, middle, and end. It says, you are not imagining things. The world really is changing. The old order really is dying, and something new really is coming, whether we are ready for it or not. That is a powerful message, especially in times when everything feels unstable and the future is unclear. And when a comet from another star appears in the sky, it becomes a focal point for those feelings, a concrete object that can be pointed to, photographed, studied, discussed. It makes the prophecy feel real, even if the connection is entirely symbolic. This is how prophecies work. They do not predict the future so much as they shape how we interpret the present. They give us a lens through which to view events that might otherwise feel random or overwhelming. They provide a narrative framework that makes sense of chaos. And when a rare, beautiful, alien object appears in the sky at a moment of collective uncertainty, it is not surprising that people reach for old stories to make sense of it. The stories may not be literally accurate, but they are true in a different sense. They are true to the feeling that something is changing, that we are standing at a threshold, that the sky itself is bearing witness to a moment that will be remembered. The idea that 3I/Atlas might be the long whispered blue star of prophecy has captured a specific corner of the internet, especially among people who blend astronomy, spirituality, and alternative history into one worldview. The connection is simple on the surface. A rare object from another star suddenly appears in the sky. It arrives at a time when the world feels unstable and uncertain. And some old stories speak of a strange star that will rise, glow, and then vanish, marking a turning point in human history. In many of the modern retellings, the blue star Kachina is described as a celestial visitor that appears as a brilliant blue point of light, signaling that the fourth world is ending and the fifth world is beginning. The details vary from teller to teller, but the core idea is always the same. A star appears, not as a gentle ornament in the sky, but as a trigger, a sign that a period of purification has begun. Old systems fall apart. Old structures crumble. Old habits become impossible to maintain. Humanity is forced to confront the imbalance it has created in itself and in the earth. 3I/Atlas is not literally a star. It is a comet, a small nucleus of ice and rock surrounded by a cloud of gas and dust when it is warmed by the sun. Scientifically, it is an active interstellar comet with a hyperbolic trajectory that proves it came from beyond our solar system. But to the naked eye, especially once it brightens near perihelion, it does not matter whether it is a star, a comet, or something in between. What matters is the experience. A new light appears in the sky. It is bright. It is temporary. It is unlike anything most people have seen before. And then, after a short time, it vanishes. Color complicates the picture. Instrument readings suggest that the surface of 3I/Atlas is likely reddish, coated with organic-rich material that has been darkened by cosmic radiation over millions of years. That is common for comets and outer solar system objects. But the coma, the glowing gas cloud, can appear bluish or greenish depending on what molecules are released when the comet heats up. Cyanogen, diatomic carbon, and other compounds can emit light in the blue-green part of the spectrum, giving the comet a ghostly, otherworldly hue. Whether 3I/Atlas appears blue to human eyes will depend on its activity level, viewing conditions, and distance. But even if it does not literally gleam bright blue, the symbolic association is almost impossible to avoid. Many modern interpreters of the blue star prophecy do not insist on a strictly literal interpretation anyway. For them, blue is not just a color. It is a symbol of coldness, distance, alienness, a sign that something from beyond the familiar sky is intruding into our world. An interstellar comet fits that description perfectly. It is foreign. It is cold. It is from beyond. It is a fragment of another star's story passing briefly through ours. The timing adds fuel to the connection. 3I/Atlas was discovered in mid-2025 at a moment when the Earth is grappling with multiple overlapping crises. Climate shifts are reshaping coastlines and weather patterns. Economic systems are strained. Social and political tensions run high. Technology amplifies both connection and division. The phrase "everything is changing" has moved from cliché to simple observation. In that context, the arrival of a rare interstellar visitor feels less like a random event and more like a cosmic punctuation mark. Articles, blog posts, and videos have already begun drawing lines between the Hopi blue star prophecy, Nostradamus-style quatrains, and the facts of 3I/Atlas's orbit. Some claim that Nostradamus foresaw a stranger star from the deep sky, approaching in an age of turmoil, and that this must refer to a comet from beyond the sun's domain. Scholars caution that such interpretations are almost always retroactive, taking vague language and attaching it to specific events after the fact. But for believers, the match feels emotionally true, regardless of historical rigor. There is also the modern reinterpretation of other symbols associated with the blue star prophecy. The dwelling place in the sky becomes the International Space Station. The spider web across the Earth becomes global communications networks, satellite constellations, and the invisible mesh of wireless signals that now surround us. The idea that many people would live in false ways, detached from the land and from each other, fits easily into contemporary critiques of consumerism, pollution, and digital isolation. When seen through that lens, 3I/Atlas arriving during this phase of history does not feel random. It feels scripted. But there is a risk here. When older traditions are taken out of their cultural context and pressed into service as proof for modern beliefs, something is lost. Hopi teachings are complex, layered, and closely tied to specific practices, ceremonies, and relationships with the land. Turning them into a simple checklist of signs to match with global events flattens their meaning and, in many cases, distorts them. Some Hopi voices have spoken out against the way their prophecies are quoted, edited, and reshaped by outsiders looking for validation of their own narratives. For them, the blue star is not just an astronomical event. It is part of a much deeper spiritual framework that cannot be reduced to a single comet. Still, the image persists. A blue star appears. The old world begins to crumble. A new world, not yet fully formed, waits on the other side of a difficult transition. 3I/Atlas's path through our system provides a ready stage for that drama. It comes, it brightens. It passes near the orbits of our planets, and then it leaves, never to return. If one is inclined to see the universe as a storyteller, the symbolism is irresistible. In the end, the question is less, did the prophecy predict this comet? And more, why do people want it to? The answer lies in the hunger for pattern, for reassurance that the chaos of the present is part of a larger cycle. The idea that a visitor from beyond the stars might be woven into ancient stories offers a sense of continuity, a bridge between past, present, and future. It suggests that the turbulence of our time is not meaningless. It is a chapter in a long, unfolding tale. Whether 3I/Atlas is the blue star or not, it functions as one. It serves as a focal point for fears and hopes, a symbol people can gather around as they grapple with the feeling that the world they knew is slipping away. The comet becomes a canvas. On it, humanity projects its anxieties about collapse and its longing for renewal. And in that sense, the true purpose of 3I/Atlas is not written in its ice and rock. It is written in us. At the end of this section, the comet stands at the crossroads of myth and measurement, prophecy and physics. But that still leaves an uncomfortable question. If the timing feels significant and the path feels precise, is it all just coincidence? Or is there something deeper in the way events line up on the cosmic calendar? But that is not the whole story. Cosmic timing, coincidence, and the calendar. Imagine compressing the entire history of the universe into a single year. On this scale, the Big Bang happens at midnight, January 1st. Galaxies begin to form in mid-January. The Milky Way takes shape by around May. Our solar system does not appear until early September. Life on Earth emerges in late September. Dinosaurs arrive around December 26th. They die out on December 30th. And everything we think of as human history, from the first cities to the internet, unfolds in the final seconds before midnight on December 31st. This is the cosmic calendar idea, a way of grasping how brief human existence is compared to the age of the universe. On that calendar, 3I/Atlas has been traveling almost the whole year. If it was ejected from its home system billions of years ago, it has been crossing interstellar space since long before our sun was born. It drifted while stars formed, while galaxies collided, while elements forged in supernovae seeded new planetary systems. Then, in the last fraction of the last second of the cosmic year, it crosses paths with a small planet whose inhabitants have just recently built tools capable of detecting it. From a purely statistical perspective, there is nothing miraculous about this. Interstellar objects probably pass through the solar system far more often than we used to think. Our ability to detect them is limited by telescope sensitivity, sky coverage, and the object's brightness. Before the discovery of 1I/Oumuamua in 2017, no one had confirmed a single interstellar object. Now, in less than a decade, there are 3 on record. As surveys become deeper and more automated, that number is expected to grow. The more we look, the more wanderers we will find. But statistics do not erase the feeling of significance. To a human being, the arrival of a third interstellar visitor during our brief moment of technological maturity feels like more than a random sample. It feels like an appointment, as if the universe has been waiting for us to be ready. We exist at the razor-thin edge of time between ignorance and awareness. For almost all of history, our species had no idea that material from other star systems might drift through ours. For almost all of the future, if we disappear or stagnate, we may not notice them again. But right now, we do. Some people look at this alignment and say it is pure coincidence. Others look at it and see intention. That split between those who accept chance and those who insist on purpose is not really about comets at all. It is about how humans handle the tension between randomness and meaning. If the universe is truly indifferent, then events like the arrival of 3I/Atlas are just that, events. The significance we attach to them lives entirely in our own minds. If the universe has some deeper organizing principle, some hidden script, then these events might be cues, signposts, on a path we do not fully understand. Certain headlines and popular media pieces have already framed 3I/Atlas in the language of destiny. Some ask whether Nostradamus predicted a rare star from the deep approaching Earth in this era, suggesting that the combination of global crises and interstellar visitors is too neat to be random. Others draw on the general sense of a turning point, linking the comet to broader doomsday narratives or spiritual awakenings. Scientific articles, of course, do not speak this way. They talk about orbital elements, spectral slopes, nush, and hyperbolic excess velocity. But in online forums, comment sections, and private conversations, the language shifts. People talk about signs, markers, chapters opening and closing. The cosmic calendar idea pushes this tension to its limit. On that compressed timeline, 3I/Atlas has been heading toward our system since long before humans existed. Nothing we did caused it. Nothing we do can stop it. Our entire history, every moment we think of as significant, is just a brief flicker in the time it has been traveling. And yet, from our perspective, the matchup feels uncanny. Just as we become capable of seeing and understanding it, it arrives. One way to think about this is to flip the perspective. Instead of asking whether the comet's timing is meaningful, ask whether ours is. Humanity evolved on a small planet, at the edge of a fairly ordinary galaxy. We developed intelligence, language, and technology, fast enough to measure the cosmic environment before the universe cooled into deep simplicity. We are alive at a time when stars still shine, galaxies are still forming, and interstellar visitors still pass between systems. In the distant future, the universe will be colder, darker, and quieter. From that vantage point, the present era is unusually lively. Seen that way, the arrival of 3I/Atlas is not a cosmic appointment with us. It is part of a broader window in which such encounters are even possible. We and the comet are both products of that window. The coincidence is not that we meet, but that both of us exist, at a time when meeting is physically possible. But humans rarely think in such detached terms. We live in stories, not in statistics, and the story that many feel now is one of threshold. The 21st century is widely perceived as a hinge point. Decisions made now will shape the climate, the biosphere, and the technological landscape for centuries. The tools we are building, from artificial intelligence to gene editing to space infrastructure, carry risks and rewards that are hard to anticipate. In that atmosphere, any rare event takes on symbolic weight. A comet from another star is almost too perfect as a metaphor, even if its actual appearance has nothing to do with our choices. Some spiritual and speculative communities talk openly about a cosmic timetable, a schedule of events that guide the evolution of life and consciousness at planetary scales. In these narratives, interstellar visitors like 3I/Atlas play the role of synchronized cues, arriving at moments when a civilization is ready to take some next step, whether that is awakening, self-destruction, or something in between. There is no empirical support for such schedules, but they satisfy a deep psychological need. It is easier to believe that upheaval is purposeful than to accept that it might be the chaotic result of billions of individual actions. Mainstream scientists, when asked about such ideas, tend to respond with gentle dismissal. There is no evidence of coordination, they say, only the workings of gravity and chance. And yet, some of those same scientists will also admit that the emotional power of these coincidences is real. They might not see 3I/Atlas as a sign, but they do see it as a reminder that our understanding of the universe is still incomplete, that we are just beginning to explore the deep structures of space and time, that our species is very young, and that we should be cautious about claiming we know the full story. The cosmic calendar, then, is less a schedule imposed from outside and more a tool for perspective. It tells us that we live in a thin slice of time, that our chance to observe and understand the universe is limited, and that encounters like this are precious because they are fleeting. 3I/Atlas is one of those encounters. Whether we label it coincidence or destiny, it is undeniably an opportunity. And that brings us to an even more concrete layer of the story, one that trades prophecy and timing for measurement and composition. Because whatever else it might symbolize, 3I/Atlas is also a physical object. And in its ice and rock, there are clues about distant suns and ancient disks, about the way other solar systems build worlds. But that wasn't the whole story. What 3I/Atlas is really made of beneath the layers of meaning humans wrap around it. 3I/Atlas is, at its core, a piece of solid matter, a nucleus of ice, dust, and rock, a frozen relic from another star's youth. Understanding what it is made of gives us one of the only direct windows into the building blocks of a planetary system that is not our own. When telescopes first began to observe 3I/Atlas in detail, they looked for the same signatures astronomers use to study comets closer to home. They measured its brightness over time, tracked how it changed as the comet approached the sun, and took spectra, splitting its light into component wavelengths to see what colors were emphasized or suppressed. These data revealed a few key things. First, 3I/Atlas behaves like an active comet. As it draws closer to the sun, its brightness increases, not just because it is getting nearer, but because its surface is warming and releasing gas and dust. This outgassing forms a coma, a fuzzy cloud around the nucleus, and in favorable conditions, it can generate a tail stretching many millions of kilometers away from the sun. The pattern of brightening and fading matches what astronomers expect from icy bodies with volatile materials near the surface. In other words, 3I/Atlas is not a bare rock or a metal fragment. It is rich in ice. Second, the color and spectrum of the comet are distinctive. Observations in visible and near-infrared wavelengths show a pronounced reddish slope, meaning the object reflects more light at longer, redder wavelengths than at shorter, bluer ones. This kind of spectrum is associated with surfaces covered in organic-rich material, complex molecules built from carbon, hydrogen, and other elements that have been altered by long exposure to cosmic radiation and micrometeorite impacts. Similar spectral slopes have been seen in distant Kuiper Belt objects, in some outer system asteroids, and in interstellar object 1I/Oumuamua. These organics are not living matter. They are not microbes or cells. They are chemistry, not biology. But they are the kind of chemistry that can lead to biology under the right conditions. On Earth, organic molecules like these can serve as feedstock for more complex structures, eventually giving rise to amino acids, nucleotides, and other building blocks of life. Finding them on an interstellar comet suggests that such chemistry is not unique to our solar system. It is, instead, a common outcome of the way ice, rock, and radiation interact across the galaxy. Third, the way 3I/Atlas rotates is intriguing. Careful brightness measurements over time show relatively little short-term variation. Most irregular objects spin, and as they do, their brightness changes as different facets catch and reflect sunlight. Large variations can indicate a highly elongated or irregular shape, tumbling chaotically. That was likely the case for 1I/Oumuamua, which showed dramatic fluctuations that led to all sorts of speculation about its nature. 3I/Atlas, by contrast, appears either fairly round or slowly rotating. Its light curve is relatively smooth, suggesting a more compact, less wildly elongated nucleus. A more spherical or slowly rotating nucleus has implications for its history. Objects ejected violently from their home systems might be expected to spin erratically, the result of gravitational slingshots and collisions. A gentler ejection, or a long time spent in the quiet of interstellar space, could allow internal stresses to dampen the rotation, leading to a more even spin. Either way, 3I/Atlas seems less chaotic than its famous predecessor, 1I/Oumuamua. Spectroscopic observations of the coma have looked for specific molecular signatures. Early data suggest the presence of water vapor, carbon monoxide, and possibly other common cometary gases, though detailed compositional analysis is ongoing. These molecules are not surprising. They are the same basic ingredients seen in comets from our own Oort cloud. What will be interesting, as more data are analyzed, is the exact ratios of these species, the presence or absence of rarer molecules, and the isotopic fingerprints they carry. Those details can reveal the temperature and density conditions in the region where the comet formed, the radiation environment it experienced, and the processes that shaped it over time. If the isotopic ratios of hydrogen, oxygen, carbon, and other elements in 3I/Atlas differ significantly from those seen in solar system comets, that would be a strong indicator that its home star system had a different chemical history than ours. If they are similar, that suggests that the processes that made our system's comets are not unique, that the same kinds of environments arise around many stars. Either outcome is fascinating. Either way, we learn something about how typical or unusual our planetary neighborhood really is. From a broader perspective, 3I/Atlas is a fossil. It is a preserved fragment of the early stages of a planetary system. Before planets form, young suns are surrounded by disks of gas and dust. Within those disks, small grains stick together, forming pebbles, then boulders, then planetesimals. Some of those planetesimals grow into planets. Others are scattered outward or inward by gravitational interactions. In many systems, giant planets like Jupiter act as gatekeepers, flinging smaller bodies into distant orbits or ejecting them into interstellar space. 3I/Atlas is likely one of those ejected pieces, a cast-off that never became a planet but carries the same ingredients. For planetary scientists, this is gold. Until recently, the only samples we had of such planetesimals came from our own system. We could send spacecraft to comets, study meteorites, and infer the rest. But an interstellar object like 3I/Atlas offers a direct sample from a completely different system. We cannot touch it, at least not with current technology. But we can study its light, its behavior, its chemistry. And from those clues, we can begin to reconstruct the conditions under which it formed. This is why observatories around the world have scrambled to collect as much data as possible during the brief window when the comet is observable. Radio telescopes, optical telescopes, and infrared instruments have all been brought to bear. Proposals have been written to secure time on the most powerful facilities. Every night of observation counts. Every spectrum adds to the story. Beneath the myths, beneath the prophecies, beneath the speculations about purpose, this is the bedrock. 3I/Atlas is an interstellar comet composed of ice, dust, rock, and complex organic molecules. It is a piece of a world that never fully formed in another star's nursery. It has traveled through the void for longer than our planet has existed, and for a short time, it is close enough for us to see, to measure, to learn from. That alone is astonishing. It means that the raw material of other solar systems is not locked away behind insurmountable distances. Some of it comes to us. We do not need to travel to another star to sample its debris. The debris occasionally comes here. And yet, for many people, that scientific description feels incomplete. Knowing what the comet is made of does not fully answer what it means. Because even as we analyze its spectra, we cannot help asking a more unsettling question. Why does this object, this silent fragment of ice and rock, make us feel so watched, so judged, so involved in something bigger? And what happened next would shock everyone who assumes the only questions that matter are the ones science can answer. Does an interstellar visitor have a purpose? This is the question that sits at the heart of everything. the question that divides rationalists from mystics, skeptics from believers, those who see the universe as a mechanism from those who see it as a story. Does 3I/Atlas have a purpose? And if it does, whose purpose is it? From the perspective of physics, the answer is straightforward and unambiguous. No. 3I/Atlas does not have a purpose in the intentional sense. It is not here because it chose to be here. It is not carrying a message, at least not in the way we usually think of messages. It is a piece of debris, ejected from another star system, millions or billions of years ago, through gravitational interactions that were chaotic, violent, and entirely mechanical. A giant planet pulled on it. A passing star perturbed its orbit. A collision sent it tumbling into an escape trajectory. Whatever the exact mechanism, the result was the same. The object was accelerated to speeds high enough to break free of its home star's gravity, and it began drifting through interstellar space. For eons, it traveled in isolation. There was no destination, no plan, no awareness. It simply moved, following the path carved by its initial velocity and the gentle tugs of distant stars. Then, by pure chance, its trajectory intersected with our solar system. Gravity bent its path inward. The sun pulled it closer. And now, for a brief moment, we share the same sky. Its path is determined by physics, not intention. It obeys the laws of motion, the equations of celestial mechanics, the same rules that govern every object in the universe. It is no more purposeful than a leaf blown by the wind, a raindrop falling from the sky, or a grain of sand carried by a river. It goes where the math says it will go. But that answer, while technically correct, feels incomplete. Because purpose is not just about intention. It is also about meaning. And meaning is something humans create. We give purpose to things by deciding they are important, by choosing to see significance in them, by letting them change the way we think or feel or act. In that sense, 3I/Atlas absolutely has a purpose, because we have given it one. It has become a symbol, a focal point, a mirror in which we see our own questions about existence, destiny, and the universe. Different communities project different meanings onto the comet, shaping it into whatever they need it to be. For some, it is a warning. They look at the state of the world, the accelerating climate crisis, the collapse of ecosystems, the political instability, the rapid technological change, and they see a species on the edge of something, either transformation or collapse. In that context, an interstellar visitor feels like a cosmic alarm, a reminder that the universe is vast and indifferent, and that our time on this planet is limited. The comet is not threatening Earth directly. Its closest approach will be millions of miles away, but its presence reminds us of our fragility, of the fact that we live on a small rock in a dangerous cosmos where extinction-level events are not just possible. They are inevitable if we look far enough into the future. For others, 3I/Atlas is a test. This idea surfaces in online forums, speculative articles, and conversations among people who believe that advanced civilizations might monitor the development of younger species. They suggest, sometimes seriously and sometimes playfully, that interstellar objects are not random debris, but deliberately placed probes, scouts sent through developing systems to observe how emerging intelligences respond. Do we panic when a rare visitor appears? Do we ignore it? Do we study it? Do we try to communicate with it? The idea has no scientific basis. There is no evidence that 3I/Atlas is anything other than a natural comet. Its orbit, composition, and behavior all match what we expect from an ejected planetesimal. But for those inclined to believe in hidden watchers, the lack of official confirmation is itself suspicious. The silence becomes part of the message. Conspiracy theories have, predictably, emerged around the comet. Some claim that governments are hiding information, that secret tracking stations are monitoring 3I/Atlas for signs of artificial origin, that the data being released to the public has been sanitized to remove anything that might cause panic. These ideas spread quickly in online spaces, where distrust of institutions runs deep. They feed on the same anxieties that fuel other conspiracy narratives, the sense that ordinary people are being kept in the dark, that the truth is too dangerous to reveal, that those in power know more than they are willing to say. The reality is more mundane. The orbital data, the spectra, the photometry, all of it is consistent with a natural object. Multiple independent observatories have studied 3I/Atlas, and their findings agree. There are no anomalies that suggest artificial construction, no radio signals being emitted, no deviations from expected behavior. The comet is doing exactly what a comet should do. It is sublimating as it approaches the sun, developing a coma, following a hyperbolic trajectory that matches gravitational predictions. If there is a conspiracy, it would require coordinating thousands of astronomers across dozens of countries, suppressing data from instruments that many universities and amateur groups can access. The logistical complexity makes the idea implausible. But absence of proof is not proof of absence, and for those already inclined to believe in hidden truths, the lack of smoking gun evidence is just more evidence of how well the cover-up is managed. There is also speculation about whether the comet could have an effect on Earth, even without direct contact. Some fringe theories suggest that interstellar objects carry exotic particles, electromagnetic fields, or subtle gravitational influences that could affect our planet's climate, magnetic field, or even human consciousness. Again, there is no scientific support for these ideas. 3I/Atlas is far too distant to have any measurable physical effect on Earth. Its gravitational pull is negligible, essentially zero at our distance. It emits no radiation beyond the ordinary sunlight it reflects. It is not broadcasting signals. It is not warping space-time in unusual ways. It is just a comet, small and cold and far away, following a path that will take it past us and then away forever. But the psychological effect is real and undeniable. The arrival of 3I/Atlas has sparked conversations, inspired articles, generated art, and prompted people to look up at the sky and think about the bigger picture. In that sense, the comet has already had an impact. It has reminded us that we are part of something larger, that our solar system is not isolated, that the universe is full of wanderers and travelers and visitors that move through the dark without ever knowing we are here. That reminder, that shift in perspective, has consequences. It changes how some people think about humanity's place in the cosmos. It makes the universe feel less abstract and more immediate. It turns distant astronomical concepts into something personal. Does that count as purpose? It depends on how you define the word. If purpose requires intention, then no, 3I/Atlas has none. The comet does not know we exist. It does not care about our struggles, our achievements, our fears, or our hopes. It is indifferent in the purest sense of the word. But if purpose is about consequence, about the ripple effects that follow from an event, then yes, the comet has purpose. It has made us think. It has made us wonder. It has made us look up. And in a world where so much of our attention is focused downward, on screens and cities and the immediate concerns of daily life, maybe that is purpose enough. There is a deeper question lurking beneath all of this, though. Not whether the comet has a purpose, but whether we do. Because if 3I/Atlas is just a random object drifting through space, shaped by chance and governed by physics, then maybe we are too. Maybe there is no grand plan, no cosmic schedule, no destiny waiting for us in the stars. Maybe we are just another accident, a brief flicker of complexity in a universe that does not care whether we succeed or fail, whether we build civilizations or burn them down, whether we reach for the stars or collapse into dust. That thought is terrifying to some people. It strips away the comfort of meaning, the reassurance that there is a reason for everything, that suffering has a purpose, that the arc of history bends towards something. But it is also liberating. If there is no predetermined purpose, then we are free to create our own. We are not following a script. We are writing it. The story we tell, the meaning we choose to see in objects like 3I/Atlas, says more about us than it does about the comet. And that freedom, that responsibility, is both heavy and exhilarating. Some spiritual traditions respond to this tension by insisting that randomness itself is an illusion, that the universe operates according to principles we do not yet fully understand, that what looks like chance is actually the unfolding of a deeper order. In these frameworks, 3I/Atlas is not an accident. It is a scheduled event, a marker, a synchronicity. The timing of its arrival, the fact that it appears during a period of human upheaval, the way it resonates with ancient prophecies, all of this is seen as evidence that the universe is more intelligent, more interconnected than materialist science admits. Other traditions take a different approach. They accept that the comet has no inherent purpose, but argue that purpose is not something you find, it is something you make. In this view, the arrival of 3I/Atlas is an invitation. Not an invitation from the comet itself, which is unconscious and indifferent, but an invitation from the moment, from the confluence of events, from the rare alignment of a wandering object and a watchful species. The invitation is to step back, to see ourselves from a cosmic perspective, to remember that we are small and brief and fragile, and to choose how we want to respond to that knowledge. Both approaches, the mystical and the existential, share a common thread. They both reject the idea that the comet is meaningless. They insist that even if 3I/Atlas has no purpose in the strict scientific sense, it still matters. It still means something, because we are here to witness it, to study it, to wonder about it. And that witnessing, that wondering, is itself a kind of purpose. In the end, the question of whether 3I/Atlas has a purpose cannot be answered with data. It is a philosophical question, a spiritual question, a deeply personal question. And the answer will be different for every person who looks up at the sky and sees that faint point of light moving against the stars. For some, it will always be just a rock. For others, it will be a sign, a message, a moment of cosmic contact. And for still others, it will be both. A natural object that somehow carries more weight than its mass, more significance than its chemistry, more meaning than its trajectory. What is undeniable is that 3I/Atlas is here. We can see it, measure it, photograph it. And for a brief window of time, we share the sky with something that has come from impossibly far away. Whether that is coincidence, fate, or cosmic timing depends entirely on what you choose to believe. But either way, the moment has arrived. The visitor is here, and the only question left is what we do with the time we have before it leaves forever. What this visitor really reveals about us three Atlas is not here to teach us anything. It has no lessons to offer, no wisdom to impart, no agenda to advance. It is a comet, silent and indifferent, following a trajectory carved into space millions of years ago by forces that had nothing to do with humanity. But in the way we react to it, in the stories we tell about it, and the meaning we assign to it, the comet becomes a mirror. And what we see in that mirror says everything about who we are, what we fear, and what we hope for. Humans are meaning-making creatures. We cannot help it. Our brains are wired to find patterns, to create narratives, to see intention where there might be none. This is not a flaw. It is the trait that allowed us to survive and build civilizations. We saw patterns in the seasons and learned to farm. We saw patterns in animal behavior and learned to hunt. We saw patterns in the stars and learned to navigate across oceans and deserts. Pattern recognition is the foundation of science, art, language, and culture. It is what makes us human. But that same instinct also makes us see faces in clouds, hear voices in static, and find prophecy in the random movements of celestial bodies. We are so good at finding patterns that we often find them even when they are not there. A comet appears, and a king dies, and we remember the comet. A comet appears, and nothing happens, and we forget. Over time, the remembered events cluster together, forming what looks like a rule. Comets mean death. Comets mean change. Comets mean something. The pattern feels real because we have selected and reinforced the data points that fit the pattern and ignored the ones that do not. When 3I/Atlas appeared in our sky in mid-2025, we could have simply cataloged it, measured its orbit, and moved on. But we did not. We asked questions. We wondered. We speculated. We connected it to ancient stories and modern fears. We debated whether it was a sign, a warning, a test, or just a rock. And in doing all of that, we revealed something fundamental about ourselves. We revealed that we are not satisfied with mere existence. We need meaning. We need to believe that our lives are part of a larger story, that the universe is not indifferent, that the things we see and experience are connected in ways that matter. This need for meaning is why prophecies exist. It is why every culture has creation myths, end-time stories, and tales of cosmic visitors bringing change. It is why we look at a comet and ask, what does this mean? Even when the scientific answer is, nothing, it is just ice and rock. Because meaning is not found in the object itself. It is found in the space between the object and the observer, in the act of interpretation, in the choice to see significance. The comet does not care what we think, but we care. And in caring, we transform it from a natural phenomenon into a cultural event. 3I/Atlas also reveals our relationship with time. This comet has been traveling for longer than human civilization has existed. It drifted through the void while our ancestors were still living in caves, while the first cities were being built, while empires rose and fell, while we developed language, writing, science, and technology. It moved through the darkness between stars, silent and invisible, for millions or billions of years. And now, for a brief moment, our paths cross. We share the same sky. We point our telescopes at it, capture its light, calculate its orbit, and try to understand where it came from. And then it will leave, accelerating back into interstellar space, continuing a journey that will outlast every human who is alive today. That brevity, that fleeting intersection of paths, is a perfect metaphor for human existence. On the scale of the cosmos, we are brief. A human life is less than a century. A civilization, if we are lucky, might last a few thousand years. Even our species, Homo sapiens, has only been around for a few 100,000 years. Compared to the age of the universe, which is nearly 14 billion years, we are less than a blink. And yet, in that blink, we have looked up at the stars and asked the biggest questions imaginable. Where did we come from? Why are we here? Are we alone? What happens when we die? What is the purpose of it all? 3. I/Atlas does not answer those questions. It cannot. It is not sentient. It is not aware. It is just matter, governed by gravity and chemistry, moving through space because that is what matter does. But it reminds us that the questions are worth asking. It reminds us that we are part of something vast, something ancient, something that stretches beyond the edges of our understanding. The comet is a visitor from another star, but it is also a visitor from another time, carrying with it the memory of a solar system that formed billions of years ago under conditions we can only imagine. In studying it, we are studying the past, and in wondering about its purpose, we are really wondering about our own. There is also a humility in this encounter, a reminder that we are not the center of anything. 3. I/Atlas did not come here for us. It does not know we exist. It is not impressed by our cities, our technology, our art, or our achievements. It is indifferent to our politics, our wars, our crises, and our dreams. It is a reminder that the universe does not revolve around humanity, that we are not special in any cosmic sense, that most of what happens in the universe happens without us, and will continue to happen long after we are gone. For some people, that is a depressing thought. It makes our struggles feel meaningless, our lives insignificant, our achievements temporary and fragile. If the universe does not care about us, then why does anything we do matter? Why bother building, creating, loving, striving, if it will all be forgotten eventually, erased by time and entropy, and the relentless expansion of space? But for others, the indifference of the universe is freeing. If the universe does not care about us, then we are free to care about each other. If there is no cosmic purpose handed down from above, then we are free to create our own. If we are brief and small and fragile, then every moment we have is precious. Every connection we make is valuable. Every act of kindness or courage or creativity is a defiance of the indifference of the void. We are not bound by a script. We are not following orders from some cosmic author. We are free to write our own story, to choose our own meaning, to decide for ourselves what matters. 3. I/Atlas will be forgotten, eventually. After it leaves our solar system, after it fades beyond the reach of our telescopes, it will continue drifting through the galaxy for eons, unseen and unremembered. Billions of years from now, it might pass near another star, might fall into another system, might be observed by another species with their own telescopes and their own questions. Or it might drift forever in isolation, never again coming close enough to anything for its presence to matter. Either way, it will not remember us. It will not carry any record of this encounter. From the comet's perspective, if it had one, this moment is meaningless. But from our perspective, it is not. We saw it. We studied it. We wondered about it. We wrote about it, talked about it, argued about it. We used it as a lens to examine our own fears and hopes, our own place in the cosmos, our own brief and precious existence. That is the story we get to tell. And in telling that story, we become part of something larger than ourselves. The cosmic calendar is not something imposed on us by the universe. It is something we are writing, day by day, moment by moment, as we choose how to respond to the world around us. An interstellar visitor appears in our sky, and we decide what it means. A crisis looms, and we decide how to face it. A question is asked, and we decide whether to search for an answer or turn away. These are the choices that define us, not as individuals, but as a species. And the fact that we are capable of making those choices, of finding meaning in a universe that offers none, of creating purpose in a cosmos that has no script, is perhaps the most remarkable thing about being human. 3I/Atlas is a comet. It is also a test, a mirror, a reminder, and a question. But most of all, it is an opportunity. An opportunity to look up, to think beyond ourselves, to remember that we are part of a cosmos that is vast and strange and beautiful, and that, in the end, might be the only purpose we ever really needed. The comet does not care if we see it as a sign or dismiss it as debris. But we care. And in that caring, in that act of witnessing and wondering and making meaning, we affirm that we are here, that we are conscious, that we are reaching out to understand the universe even as we struggle to understand ourselves. That act of reaching is what makes us human. And as long as we keep reaching, keep wondering, keep looking up at the sky and asking questions that have no easy answers, then we are fulfilling a purpose that we have chosen for ourselves. 3I/Atlas will leave soon. By the end of December 2025, it will have faded from view, accelerating back into the interstellar void. The window of observation will close. The data will be archived. The papers will be written. And eventually, the comet will be just another footnote in the history of astronomy, remembered mostly by specialists and enthusiasts. But the questions it raised, the conversations it sparked, the moments of wonder it created, those will linger. They will shape how some people think about the universe, about humanity, about what it means to live in a cosmos that is indifferent but not empty, silent but not still. And maybe that is the real purpose of 3I/Atlas. Not to deliver a message, but to be a canvas. Not to answer questions, but to provoke them. Not to tell us who we are, but to give us a chance to decide for ourselves. The comet is what it is, ice and rock and ancient dust. But the meaning we find in it, the stories we tell about it, the way we choose to respond to its brief passage through our sky, that is entirely up to us. In the end, the cosmic calendar is not written in the stars. It is written in the choices we make, the meanings we create, the connections we forge. And as 3I/Atlas fades into the distance, as it disappears back into the black from which it came, it leaves behind a question that each of us must answer for ourselves. Not, what was the comet's purpose? But what is mine? That question echoes long after the visitor has gone.